All right, welcome everybody. My name is Zach Snyder. I'm with the nonprofit Solar Oregon, and you are on our How to Go Solar and Storage webinar. I have a little bit of a cold, so hopefully my voice is understandable. If I break into a fit of coughing at any point, I apologize, but I should be just fine, and I'm excited to be here with you. You are in a workshop that we put on pretty frequently. I'm going to show you what we're going to talk about here. This workshop is for anybody who may be a home or business owner or part of an organization that is considering rooftop solar or any kind of solar, also battery storage or energy storage. And so if that sounds like you, then you are in the right place. And we are going to go through how does solar work. We're going to go through the basics of the technology, talk about a system called net metering, and how solar saves you money on your energy bills. Then we're going to talk about, is my site right for solar? We'll be looking at what makes a site a good fit for solar in terms of are there going to be any obstacles that will increase cost or just make it so that you can't go solar at all. Then we'll take a look at energy storage, which is a large and exciting new topic that we are increasingly being asked about. And then we'll go over the incentives that will help you to access both solar and storage, and we'll end with how to get started. This webinar should run roughly 40 minutes, and we'll end with a Q&A. And I would love to answer all of your questions about solar, all of your questions about energy storage. So wherever you are in your journey, this is a great place to get those questions answered. A little bit more about Solar Oregon. We're a 40-year-old nonprofit. We educate and advocate for the increased adoption of solar energy in all of its forms, as well as other related clean technologies like batteries, like electric vehicles, or energy efficiency. And we do this through webinars and workshops like the one you're in right now. We also put on tours like our annual Zero Energy Homes Tour, the Go Zero Tour, which happens in October. It's a great way to take a look at sites that have a lot of these different technologies and just ask people what it was like for them and hear their stories. And we also perform campaign-based work, including Solarize campaigns. We're a pretty small organization. I currently am the only staff. The picture here on this slide is of myself and my former coworker who now works at a battery company, and we have just hired her replacement. So we're about to be back up to 2 people pretty soon. We're a member-based nonprofit. We serve all parts of the state. And huge thank you to anybody who is a member of Solar Oregon. If you're not a member and you want to become one, you can go on our website, become one there. There's also a link here to donate to our nonprofit. We hugely appreciate any support, any and all support. So I'm gonna go ahead and drop a few links in the chat right now. You can refer back up to them as we are going through. It includes a link to our website, to upcoming events, our donation link, and a few links to some of the incentives and other organizations I'll be talking about today. So in addition, I'd like to thank Energy Trust of Oregon. They are an independent nonprofit. They've also been around for some time. They serve the customers of Pacific Power, Portland General Electric, Northwest Natural, Cascade Natural Gas, and Avista, basically all of the large utility companies in the state, and provide great incentives for renewable energy and for energy efficiency and help save a lot of energy across the state. And they also support great educational programming like this webinar. So thank you to Energy Trust of Oregon. And one last thing before we get started, I like to make this event as interactive as possible. So you likely have been on a Zoom call over the past couple of years during COVID. But I want to point out a couple features. There is a chat box. So you should have a menu over if you mouse over the lower part of your screen, I believe, there's a menu with different buttons on it, including a chat button. Feel free to go into the chat. That's where I've posted these links. And you can also say hi and just talk to other people in the chat. There's also a Q&A button, and that's where we're going to be collecting all the questions for the Q&A at the end. You can put a question in during any part of the webinar. So if you have a question you want to ask right now, feel free to just open it up right now in the Q&A box and start typing your question. I'll get to that again at the end. I see that someone is posted in the chat. You don't see the links. I'm going to go ahead and put them in the chat again. Oh, there we go. It looks like the first time I was just chatting with myself. So I just put the links in the chat. Let me know if you don't see them anymore. And the last feature that I want to show you is that I love to conduct polls during these webinars. So this is a great way for me to get to know who you are and how best I can talk about solar and storage today. So I'm going to launch our first poll, and you should see a question that's come up in a box on your screen. Go ahead and take a second and fill that out. The question is, where are you joining from? And you might be in Portland, you might be in the broader Willamette Valley, Oregon coast, Eastern Oregon, another state, international. So go ahead and click your option and then hit submit, and we'll move on in a second. All right, looks like I've got most responses back. Just going to give you a couple more seconds. Hey, Kate, welcome. Great to have you. Where in Central Oregon you're from? Go ahead and end this poll. Oh, cool. A couple of people from Bend. That's great. Welcome. Glad to have you here. I've got a couple more polls. This one is optional and anonymous. Won't share this out. This is just information about demographics to help us know who we're serving. So if you would take just a minute and fill it out. Excuse me. All right, looks like we have most of responses. So I'm just gonna give a couple seconds. And then I will end this poll. Sandy, you'd like to see the response to the location poll? I'll see if I can pull that up and share that. All right, gonna go ahead and end this poll. Maybe, yeah, I'll do that after this final poll. And so if you would answer this last final poll, this is for us to get a sense of how familiar folks are with a couple of incentives that I'm gonna be talking about today. The first one is Energy Trust of Oregon Standard Solar Incentive. And the second question is about Energy Trust of Oregon's Solar Within Reach incentive, which is a different incentive. If neither of those ring a bell, feel free to click the no option on both of them. Or if you're not sure, you can click not sure. All right, got everybody there. Share the results here. Cool, so it looks like we got a mix. Some folks are aware of these incentives. That's really great to hear. And for everybody who's not or who's not sure, you will surely be aware of them after the end of this webinar. So glad to have you here. And then see if we can share out. Yeah, here's the results from the location. Looks like we got some folks from Portland, a few folks outside of Portland in the Willamette Valley, a few from Eastern Oregon, and somebody from out of state. That's great. Great to have all you on here. All right. So without any further ado, let's jump into how solar works. So, oh, whoops, missed a slide there. Here's a diagram of a solar system. I'm gonna walk you through it. Obviously, the solar panels that you see on the upper left, these photovoltaic panels with all the blue squares, there's just one panel here in the image. That might be on your rooftop, but here on the image is just floating in space. And the panel is there to collect sunlight. And when the sunshine hits the panel, it produces electricity, produces a voltage. And that is really as simple as it is in terms of what the panels do. There's no moving parts, and they just sit there and collect sunshine, turn it into great electricity. There's one other function of a solar system in the most basic way of looking at it. And that is to convert the electricity from DC to AC form of electricity. So there's two types of electricity. There's DC and AC. Your home uses AC. Solar panels produce DC electricity. So to perform this conversion, we have an electrical box called an inverter, or we have a set of boxes called microinverters. And that's all they do is they perform that function. And once they have converted the electricity to AC, it goes into your home's electrical panel. It's wired in there. The electricity that's produced from the sunshine that hits your panels then gets routed to all the circuits of your home. It powers all of your lights, your appliances, and it can power either the entire electrical load that you're using at any given moment, or maybe if it's nighttime and you're using electricity, you can also draw electricity from the utility grid still. And so you have access to both your solar panels and the utility grid. If you are producing more electricity than you're using at any given moment, that excess electricity from your solar system actually goes back out through your utility meter and onto the utility grid, where it can be used by other customers of the utility. And so you can see that electricity is coming into your home through the utility grid and also potentially going out. And an interesting side note, when you get a solar system, typically what you have before you go solar is a one directional meter. Your utility meter will only record the electricity coming into your home from the utility grid. When you go solar, your utility company will come and swap that meter out for a bidirectional meter, which can measure the electricity flowing in both directions. And that's important because then on those really sunny days, maybe you're out of the house and for a while you're just exporting a ton of electricity out onto the grid. You're able to record that, and that allows you to get credit for it. So I'll talk about that system of crediting and recording your electricity in a couple of slides here. But this is the basic gist of a solar system. It's a very simple system, and that has a lot of benefits. So here's an image of an inverter and some microinverters. The inverter is on the left. It's the white box here. The inverter is something that goes typically next to your electrical panel. That's your breaker panel. If your breaker panel's in your garage, then and you have space on the wall in your garage, that's an excellent place for your inverter. That's probably where your solar installer is going to put it. Here in the image, it's shown on the outside of the home, which is also a just fine location for a solar inverter. On the right side of this slide, you can see the underside of a solar array. So you're looking up from beneath, and you can see these little black boxes with some wires on them. And you see a number of those boxes. Those are the microinverters. And those microinverters are doing the exact same thing as the inverter. These are two different system types. You can either have an inverter or you can have microinverters. There's no clear-cut case as to which is better. And when you're talking to a solar installer, they might advise you as to which one might be slightly better, or they'll walk you through the pros and cons of each for your situation. Solar can be mounted, most typically it's mounted on the roof, but it can be mounted on the roof or also on the ground. You might have a ground mounted solar installation if you have A, enough space, and B, you have maybe a reason why you want to put it on the ground instead of your roof. For example, if you are about to re-roof and you, or you might re-roof in a few years, then that could be a situation where a ground mount could be preferable. Ground mount is not very common in urban environments where there's not enough space. It's more common in rural environments. Where you do have a ground mount, you will notice that there will be a little bit of extra cost because the contractor will have to trench and route a wire from the ground mounted installation all the way back to the electrical panel in the home. Roof mounted solar is an excellent option, and it is what is by far most common in more dense urban areas. But these are both great ways to mount solar. So I mentioned that you can export excess energy from your solar system onto the grid and get credits for that. I'm going to describe to you that system right now, which is called net metering. And I have two charts here. Basically, what I want to show you is a typical summer month, which is the chart on the left, and a typical winter month, which is the chart on the right. The orange bar in these charts is how much electricity you're producing over the course of that whole month from your solar system. So you can see on the left where it's a summer month, it's really sunny. The orange bar is much higher. The blue bars are how much energy you're consuming in your home. And that might be from your lights, your appliances, charging an electric vehicle, things like that. And in the summer, you might expect that your solar system is producing more energy than you're consuming over the course of a month. At the end of the month, you will get credits for whatever excess you've produced. So that's that green bar there that shows the difference between the orange and the blue bars on the left chart. So in the summer months, you're banking up credits when it's nice and sunny. In Oregon, we tend to have cloudier winter months. And you can see on the chart on the right, the orange bar, the amount of electricity you're producing with your solar system is lower than what you're consuming. And that's that red arrow shows that difference there. So that's what you would pay the utility. However, because you've banked up credits in the summer months, you will have those credits to be able to use for to offset that cost in the winter months. And in this way, you're able to essentially equalize between these summer and winter months. And this is the system is called net metering. The one thing to note is the net metering calendar doesn't start on January 1st. It starts on March 1st. And that is because your credits, although they roll over from month to month, they don't roll over from year to year. And they start the net metering year on March 1st, because that's when the sun comes out, you start producing a lot of credits, which you can rack up in the first part of the net metering year. And later on, in the end of the net metering year, up through February 28th, you're able to use those credits. And if you happen to have a few extra credits, those will be donated to, I believe, a low-income fund for folks to get assistance with their energy bills. I saw there was a raised hand. Go ahead and If you have questions about this, I would love to answer them. I am going to answer them at the end in the Q&A section. So go ahead and put those in the Q&A box, and I'll be sure to get to those at the end. So this is the system of net metering, and solar, one of the main benefits of it, and a great reason why there is such an increase in the amount of solar being installed around the state and around the country, is that solar allows you to reduce the amount of money you pay for electricity. There is the upfront cost of a solar system, but the energy that you produce offsets what you buy from the utility company. Over a period of time, your system pays for itself through those energy savings. And after that payback point, you're essentially saving money thereafter with your energy system. And so that is the great benefit beyond, of course, the great planetary benefits of it being just clean energy. So that's how solar works, and it's relatively simple. Now let's talk a little bit about how you know if your home, is right for solar, what makes it easy or difficult to install on a particular home or business. First thing I'm going to talk about is system size. The first thing that impacts, the most important thing that impacts the size of your system is how much electricity you consume. So a solar system is very modular. You could have just a single panel, or you could have any number of panels. You have massive solar farms in California, for example, or in parts of China that are the size of small cities, essentially, and they produce a ton of electricity. The typical size of a rooftop solar system, residential rooftop solar system in Oregon, is between roughly 6 panels and 40 panels. And so you really want to dial that into how much electricity you consume. And that's because of what I just went through with regard to net metering and the fact that your net metering credits, although they roll over from month to month, they don't roll over from year to year. And so you want to size your system so that it meets but does not exceed your average expected electrical consumption on an annual basis. This is something that solar contractors do day in and day out, and they're really pretty good at estimating how much electricity you're going to need based on your past usage. Other factors that can affect the system size are the amount of available space on your roof. Maybe you don't have quite enough space to offset 100% of your needs, but you have enough to offset 80% or even 50%. That can still be a great investment. Your budget may limit you. Maybe you want to install on half of your roof area now, and you know that you'll want additional panels in a few years' time, but you want to save up for them. That's something you can do. I would certainly encourage you to talk with your contractor at the time of installation to make sure that they're installing the system in a way and designing in a way that will make it as easy as possible for you to add those additional panels. And quick note, the size of a system is measured in something called kW, that's kilowatt. That's a nameplate rating. You don't have to worry about what that means, but the average size system in Oregon for a residential solar system is 6 kilowatts, which is about 18 panels. So, beyond system size, I want to talk a little bit about solar access, the access that you have to the actual solar resource that's falling on your property. This is a diagram of a hypothetical home with a solar system on it and the path of the sun over that solar system. So you can see that because we're in the northern hemisphere, the sun travels from east to west in an arc in the southern skies. And so what that means is that south-facing roofs are ideal for solar. North-facing roofs really don't work for solar. It is technically possible to angle the panels up so that they're facing south, even though they're on the north face of the roof. It looks really strange. If you really, really want to do that, you could ask your contractor if they would do that for you. It does add a little bit of extra cost. But really, solar is pretty much only installed on the southern-facing roofs or the eastern and western-facing roofs. Those east and west-facing roofs are also typically great. West-facing can be slightly better because we have slightly misty mornings. And so when the sun is in the eastern sky in the morning, you might get slightly less solar radiation reaching your roof. And so western roofs and southern facing roofs are the gold standard. East facing roofs can also work. North facing roofs, not so much. Of course, you may have a perfect south facing roof, but if you're covered in trees, that could block your sunlight enough that it's not really viable. It's technically possible to install solar anywhere, of course, but if it's shady, you'll just get much less production on it. So there are situations in which shading, especially here in Oregon, where we have so many trees, can be an issue. I have been surprised where by sites that it really seems when you're there that it seems like there's a ton of trees and there would be too much shading, but actually the roof gets plenty of sunlight. And I've seen sites where it looks like you have a wide open sky, but there's just that one tree on the south facing side of the house that blocks most of the sunlight. So the best way to determine this is to call a solar contractor and have them look at your home on Google Maps, and they can weed out most homes that are too shaded just by looking on Google Maps. So it's a pretty easy process. And then if they're uncertain after that, they might come to your home and measure the amount of sunlight you get on your roof. The shape of your roof, the geometry of your roof also can impact the ease with which you can go solar. Here, I portray this just as the difference between a complex roof and a simple roof. On the left is an image of a home where the roof is broken into a bunch of different roof planes. You could certainly install solar on some of those roof planes. The size of the system might be smaller than if that was one contiguous roof plane. And so if you have a very complex roof type, it doesn't mean you can't go solar, but if you have a very simple roof type, especially if it's south facing, that is great for going solar because you can have that continuous system. And it's just easier to find the area to install those panels. Additionally, your roof condition does impact whether it's a good idea for you to go solar. So you'll want to make sure that at the minimum, you have 10 years of roof life left. Really, ideally, it'd be great to have 15, even 20 years of roof life when you are installing solar. And the reason for that is that when you re-roof, which is not optional, when you get to the point that you need to re-roof, you need to do it. When that happens, you will need to uninstall your solar system, change the roof, and then reinstall the solar system. And that uninstallation and reinstallation of the solar can add several $1,000s of cost. So it's something that you want to avoid if you can. Obviously, installing on a brand new roof is ideal. Metal roofs last a long time, and so typically not an issue at all unless it's just a very, very old metal roof and it's in poor condition. Asphalt shingle roofs are great for solar. You just do want to get on the roof and make sure that it's got enough life left for you. Finally, the structure of the roof, the internal structure of the roof, can have some impact on the cost of a solar system. This is mostly an issue within Oregon. It's mostly an issue in Portland. And that's because Portland has incredibly strict building codes, and it requires that you have a very sturdy roof to go solar. And the concern, the reason those codes exist is not because the solar panels are heavy and they weigh down on the roof. It's actually because the solar panels rest several inches above the roof. And as the wind blows over the panels, it creates a shear force that actually pulls the roof slightly upward. And like I said, Portland happens to be particularly strict about it. Other jurisdictions, you won't have as much of an issue. In Portland, you can either, if your roof fits into their set of parameters that shows that it's clearly a strong enough roof, you won't have to do any engineering or reinforcement of the roof. If it falls without the parameters, you may have to hire an engineer to look at it. And if that engineer determines that reinforcements are necessary to meet Portland's code, then you would need to install some reinforcements. Both the cost of the engineer and the cost of the reinforcement, which is done by the solar contractor, are additional costs. The engineer is maybe around $700 to $1,000 to get an engineer to look at it, and reinforcement can add several $100s on top of that. On the left here, I have an image of an attic with trusses. So this attic has the vertical and up top the horizontal support beams. And you can see even these metal brackets at the connector points between the beams and the main rafter boards that run along the actual roof plane. Those metal connectors, if you have those and you have these supports in your attic is A-okay, because that means you have prefabricated trusses. And so your roof should definitely pass any jurisdiction's code requirements. If you look in your roof, in your attic, and you see just rafters with no support beams, that does not mean that you will incur extra cost with an engineer or reinforcement, but it could. And really, it's a matter of whether those rafters span too far of a distance. And so your solar contractor will get in there, take those measurements of how far those rafters span, check it against a chart, and determine whether engineering is required. Then the engineer will determine whether reinforcement is required. However, it is extremely rare that your roof is just not suitable at all for solar. So the good news is, even though in the worst case, it may add a little bit extra cost, it probably won't prevent you from going solar. So let's move on to storage, which is means essentially a battery for your home or business. This, again, is a really exciting topic. We get lots of questions about this, and this is a newer market than solar is in Oregon. So when I talk about storage, I like to talk about energy resilience. And what that means is that when the grid goes down, so you can see that this image is just of a power outage, it's really nice to be able to have some power, and you can do that with a battery. It's important to note that solar alone does not give you this ability. If you add, a lot of people think that once you go solar, you can use your lights and your appliances because you have solar without a battery. When the grid goes down, that's simply not true because of certain electrical codes, and also the amount of energy that you would need doesn't exactly match what your home's producing at any given moment without a battery, just with solar. But if you add a battery, or if you even had a home with a battery and you didn't have solar attached to it, that's when you can start to use your energy when the grid goes down. And additionally, solar, when you add solar onto a battery system, the solar can then recharge the battery system. It makes your battery system more effective, allows you to last through a longer outage. So quick couple of notes on why energy resilience matters. So most outages are caused by storms and squirrels. Additionally, recently, there are times when the utility companies in Oregon have started to shut down parts of their grid, not the entire grid, but just parts of it, when it looks like there's high fire danger. And that's called a public safety power shutoff. Those happened, you may have remembered them from news reports in California, when the utility started shutting down parts of the utility grid there. The utility grid down there, they started doing that because the utility grid was identified as a main risk to starting wildfires. And so in order to prevent those, they just shut down the grid. Unfortunately, that leaves a lot of people without power. There have been public safety power shutoffs in Oregon starting in 2020, and they tend to be in more rural areas. Additionally, although there have not been many cyber attacks that have brought down the utility grid, that is identified as a main vulnerability of the grid, and another reason to consider energy resilience. And finally, we live in the Cascadia seismic hazard zone, and even in Eastern Oregon, you guys will feel some shaking. If you're in the Willamette Valley, that's when you'll really be impacted by the earthquake. It is estimated that the power might go down for 6 weeks in the Willamette Valley area after the large quake. So that's a few reasons why this topic is increasingly of interest. And again, solar and storage, here's what it looks like. You might have a battery in the garage, solar on the rooftop. This really is the peanut butter and jelly ideal combination for energy resilience, because the sun will always be shining on your solar panels and your battery will be able to collect that energy and allow you to use it. So what are battery systems? What do they look like? What are the options? There are several options for battery systems. A lot of people are aware of Tesla Powerwalls. However, there are other batteries that are sold pretty commonly here in Oregon. We are brand agnostic, so I don't recommend any of these technologies over the other, but talk to a solar contractor, and solar contractors are the ones who are installing these batteries. It's really important, if you're considering a battery, to set your expectations as to what a battery can achieve. A lot of people have this notion, oh, I'll get one battery and then I'll be able to last for a week with my whole home, and I'll have my jacuzzi on, have my electric vehicles, no problem. That's not actually realistic. And so it's what you'll hear when you talk to a solar contractor who installs batteries is, well, do you want a partial backup or do you want a whole home backup? Partial home backups are the most common. That's where you'll take a portion of the circuits in your home. I'll talk about how that works in a second. You'll take a portion of the circuits in your home and you'll wire just those circuits to your battery. So you'll be able to use specific things in your home, but not other things. Or if you want a whole home backup, your contractor, either way, will go through and figure out what are the appliances that you use, how much energy do all of them use, what's your average energy consumption for using, part or all of your home circuits. And then the contractor can tell you, here's how many batteries you would need for a whole home backup. And here's what one battery could help you achieve given the circuits that you use. So there's a little bit of a planning process. It's a little bit of a conversation you need to have with your contractor. But this is the first question I'll ask. A whole home backup, this is just showing you, it is possible to install multiple batteries. Note that batteries are not cheap, of course. They come with cost, and it can be a substantial cost. And you really need to weigh that and balance that with what your actual needs are. Do you need the entertainment system running during your outage? Things like that. And what you will do if you don't want to pay for a whole home backup, say you just want one battery, and you're trying to decide the best way to use that battery, a couple of questions you'll be asking yourself are, what needs power and for how long? So the most important things to back up typically are things like your refrigerator, so your food stays good. Maybe you have medicines that need to be refrigerated. Some lights in critical parts of the home, like the kitchen, maybe in the bedrooms, things like that. And maybe some outlets, so you can charge a computer or a cell phone and maintain your communications with the outside world. That is typically what you look for in a partial home backup. And of course, you can add things onto that list, but you're going to decrease the amount of time then that all of those things can be used when there is an outage, the more you add to your battery. And so the second question is, for how long do you want to be able to persist through an outage? Maybe you are getting a battery because you're in a rural area and you experience many frequent outages that are of shorter duration. And so you want a battery to last you for maybe even just 3 hours, but to be able to do that frequently. In that case, you might be able to add more circuits onto your battery and still get away with that shorter duration of being able to use your battery. If you are more concerned about something like public safety power shutoffs, which might be 24 hours, something like that, or 12 hours, or the Cascadia seismic zone, which might, a large earthquake, might be many days, obviously it'll be very expensive to, and probably certainly impractically expensive to wire your home up for long enough that you can persist through a many-week outage. So those are the two things you need to balance: what needs power and for how long. When you get a partial home backup, I've been talking about how you need to select the circuits. The way you do that is you go to your breaker panel, and your home is already wired so that each one of your breakers corresponds to a set of circuits. You know, those might be appliances or outlets in your home, and you go through and select which ones you want to be backed up. And your contractor will actually remove those breakers from your main breaker panel, install a separate breaker panel, which is like the one you see here in this picture. It'll be a little bit smaller. Those are your essential loads, and only that panel gets wired up to the battery. So that's how you can essentially select which parts of your home are backed up with a battery. That's a basic overview of solar and storage. And again, if you have questions at this point, continue to put those in the Q&A. I see we have some questions building up there. So we'll get to those. First, I am going to talk a little bit about the financial side of solar and storage and the incentives available. So this is a chart that shows the cost of solar over a 10-year period from 2010 to 2019. And roughly the last decade. And you can see that the cost has been cut by more than half during that time. And that is just because the industry has grown. We have access to larger economies of scale, and solar is just cheaper now, which is excellent for everybody. And so you're just starting with a cheaper product. The solar continues to decline in prices, not quite as fast as it did between 2010 and 2019. However, it is expected to decline in price into the future as well. And so we have access to cheaper solar to begin with. On top of that, we have incentives. There are three primary incentives that I'll talk about on this slide. There's the solar investment tax credit, excuse me, which is a federal incentive. And it is a tax credit, not a tax deduction. And so it is a dollar for dollar discount on your solar system that you get back on your tax refund the following year after you install the system. And so you pay for the system and then you get that back on your taxes the following year. It is important to note that you have to have tax liability to take advantage of that. I believe you can take advantage of it over the course of a couple of years. So if you don't quite have the tax liability in 1 year, you may be able to do that over a couple of years, though there's a limit to that. And the solar investment tax credit is governed by federal tax law. And so if you have specific questions about that, I would love to answer them, but really a tax professional is the one who will help you navigate that. The second incentive I'm going to talk about is the solar and storage rebate, and that is offered from the state of Oregon. And that is available to anybody in Oregon, whether you're in one of the large utilities or in a smaller co-op or a municipal utility or public utility district. And the solar plus storage rebate is, I'll get to some numbers here. The solar investment tax credit was 26%. So that's a very large and generous incentive. The solar plus storage rebate is up to $5,000. And that is for the solar. There's also up to $2,500 for energy storage for a battery. And when I say up to, that's based on the size of the system. So that $5,000 can only pay for a certain percentage of the cost of a system. I'll get into that in more detail on a slide here just in a second. Energy Trust of Oregon also provides incentives. Note that the Energy Trust of Oregon incentives are only available to customers of Portland General Electric, which would be $1,200, or Pacific Power, which would be $900. This is the standard solar incentive. So if you're outside of Energy Trust territory, maybe you have a co-op or a muni or a public utility district, then you won't have access to the Energy Trust of Oregon incentives. However, most of you are probably in Energy Trust territory. So those are the standard solar incentives, which are obviously great. In addition, Energy Trust of Oregon, so again, for PGE and Pacific Power customers, there is an additional incentive called the Solar Within Reach incentive, which you get either the Solar Within Reach or their standard incentive. And the difference is whether you are income qualified, if you're in a certain income bracket. So if you, for example, are a household of 4 residents and your household income is below $106,944, that's the cutoff there for household of 4, you will have access to Solar Within Reach. You can see a chart on online. I'm going to go ahead and put the my links back in the chat here. You can see the Solar Within Reach incentive is the last link before my presenter contact email. You can see a chart on that website that shows you the income thresholds at different household sizes, but this is a much larger incentive. And so Pacific Power customers can receive up to $4,200. And that's it's $1 per watt incentive. So it's based on the size of the system. Portland General Electric customers can receive up to $8,400, which is very large. And that's also $1 per watt system. And I will show you an example budget in a second, so you get a sense for where you get to that maximum incentive threshold. But that's the Solar Within Reach incentive. Again, that's Energy Trust of Oregon, and it's if you are income qualified. I want to talk also for a second about the state's solar plus storage rebate. That was the second incentive that I showed you. That's the $5,000 for a solar system or $2,500 for a storage system. And those are the maximum dollar figures, and those can account for up to 40% of the system cost, which means that even the average size solar system will receive the full incentive here. And if the applicant for this incentive is under a certain income threshold, which is defined on the Oregon Department of Energy website, it can account for up to 60% of the system. So even if you had a very small system, if you are income qualified, you could still potentially get the full incentive amount. I just want to add that additional information for you about this incentive. So that may be a lot of information about different incentives. I want to tie all of this together for you in a sample budget. And this is often people's favorite slide because everybody's wondering how much does solar cost and what do these incentives actually do? I'm excited to show you this example budget. You should note that quoting this, or estimating the cost of a solar system is very difficult. And that's because, as I mentioned before, solar systems can vary greatly, both in their size. So maybe you have a small system that's 6 panels, maybe you have a large system that's 40 panels. The cost of that system is going to vary widely. In addition, if you had to hire an engineer or do any reinforcements structurally for your roof, that could add additional costs. So take this budget with a grain of salt, but let's assume the average size of solar system. Remember, that's a 6 kilowatt system. And we're going to assume an average, which is a reasonable assumption, an average initial cost of $20,000. So you can see in the left column here, we're going to run through these different steps of adding the incentives. The middle column is for a non-income qualified family installing solar, and the right column is if you have access to the income qualified incentives from Energy Trust. So we start with $20,000, and the great thing is your solar contractor applies for every incentive for you except for the federal income tax credit. That's something that you will do with your tax preparer when you prepare taxes the following year. Everything else, all the paperwork is handled by your contractor. So your contractor applies for and receives either, if you're non-income qualified, a $1,200, sorry, this, I have to note, this initial budget is for Portland General Electric customers. I'll go through Pacific Power customers on the next slide. So your energy trust incentive is either $1,200 if you're non-income qualified, or you get the solar within reach incentive, which is $8,400. So that's going to lead to a net cost. This is still not your out-of-pocket cost. So that's either $18,800 or $11,600 if you're income qualified. In addition, if you apply for and receive the state solar plus storage rebate, that's on this chart, it's called ODO rebate, you will get $5,000 additional dollars off your system. So the out-of-pocket cost to you after those two incentives will either, if you're non-income qualified, come to $13,800, or if you are income qualified, to $6,600. So you can see that they already reduce a lot of the system cost, which is great. In addition, if you have the tax liability, you can apply for that 26% federal tax credit, and that will take the final net cost of the system down to $10,212 if you're non-income qualified, or just under $5,000 if you are. So the incentives make a big, big difference, especially if you're income qualified in Portland General Electric territory. Let's go ahead and run through the same budget example, but for Pacific Power. So we're going to start with the same $20,000 cost. I'm going to run through it a little bit quicker. The energy trust incentive is either $900, or if you're income qualified, you get solar within reach, which is $4,200. Add to that the solar plus storage rebate, still $5,000. And the out-of-pocket cost to you, a Pacific Power customer, for this average 6 kilowatt solar system is $14,000 if you're not income qualified, or just over $10,000 if you are income qualified. And then after the federal tax credit, if you have that tax liability, drops even further to the about $10,000 for non-income qualified, or about $8,000 for income qualified. So hopefully that gives you a great sense for how much an average solar system costs. And I hope that that information is useful for you. Do not be surprised if the actual quotes that you receive differ from this example, again, because of the size of your system or because of certain characteristics of your site that make it more or less easy to install on. So finally, before the Q&A, which I'm excited for, we are going to go through how do you get started installing solar or storage. And if you are a customer of Portland General Electric or Pacific Power, or even if you're not, but especially if you are, I highly, highly recommend that you use a trade ally contractor. What a trade ally contractor is a contractor that's been rigorously qualified and vetted by Energy Trust of Oregon to make sure that they meet high standards of solar installation, battery installation. And these Energy Trust trade allies are the only installers that you can use if you want to receive Energy Trust of Oregon incentives. You can still receive the other two incentives, the state incentive and the federal incentive, if you use any contractor. That won't affect those incentives. However, in order to receive Energy Trust incentives, you have to use a trade ally. There is an excellent tool that Energy Trust of Oregon has put together for folks who want to consider solar. This online tool, it's called the Solar Bid tool. And I would refer you to the links that I put in the chat again. This is the Energy Trust Solar Bid tool link. That online tool takes about 2 to 5 minutes to fill this out. You fill in some of your personal information like your address and your contact information. It will be sent to 3 randomly selected but highly qualified trade ally contractors who serve your area. Those contractors you will know will be well qualified to install a solar system at your site, and they will reach out to you and offer you a free quote. So if you're at the stage where you're ready to compare quotes, go ahead and use this tool from Energy Trust. It's a really easy way to be connected with high quality contractors and several of them so you can compare them. Once you have compared several quotes and you've talked to your contractor, gotten a sense for who they are, and decided this is the contractor from me and this is the system that I like the best, you will sign the contract for your system. There may be an upfront payment. Some contractors may have an upfront payment and then payments after the system is installed, may be structured in slightly different ways. But once you sign the line, the contractor performs all the work. So it's a turnkey service. So they're going to design your system. They're going to handle all the permitting, all of the incentives. And there will be a little bit of time after you sign where they're doing this preparation work. There also may be a little bit of time before they can get you on their construction calendar. But once they do, the installation typically only takes 1 to 2 days. And for standard residential systems, it's increasingly common to just do a 1-day installation. So it's relatively painless. And the contractor will manage all of the inspections afterward. They will manage your meter swap to get you your new bidirectional meter. And they will manage the interconnection process with the utility. Once your meter is swapped, the city has signed off on your inspections and your utility has approved your net metering interconnection. Your system will be turned on by your contractor, and you should have a monitoring system. So you'll be able to see the energy that's being produced from the sunshine, from the solar panels on your own roof. And I've heard it's a great feeling. So that is the installation process. And we have now wrapped up our workshop. And I'm excited to get to the Q&A. I'm going to go ahead and put my contact up here before we actually do that, so you can jot that down. I am happy to answer any questions we don't get to today. So please feel free to email me at zachs@solaroregon.org. And additionally, before we actually dip into the Q&A, I have a post-event survey that I've turned into a poll because I found that it's a much better way to get people to fill out a survey is to put it into a poll. So if you would take just a minute or so and fill out these questions, it really does help me learn how to improve our webinars and workshops in the future. And if you have further feedback, you can always get in touch with me directly, zachs@solaroregon.org. So as you are doing that, I am going to open up the Q&A box. I see 6 questions in here. Again, feel free to continue to put questions in, and I will try to get through all of them before we jump off. So first question I see is, do you collect sunlight on cloudy days? That's a great question. It's a very common question because obviously we have a perception that Oregon is rightly very cloudy and rainy, and it is. First off, I will just note that solar works excellent even in the rainiest parts of Oregon. The rainiest and darkest parts of Oregon are still sunnier than pretty much the entire land area of Germany. The reason I bring that up is because Germany is the most solarized country per capita. Solar works great in Germany, even in the Nordic countries north of Germany. The difference between a sunny day, a bright, cloudless sunny day, and a dark, rainy winter day, there is definitely a difference in how much energy is being produced between those two moments by your solar panels. And you will notice that difference. Are they still producing electricity? Yes, they are. And you'll see that the electricity is being produced even on the darkest day, but it tends to be very, very little. Kate, you ask, does wildfire smoke impact solar charging? It's a great question. Yes, it does. And there have been studies on it. Obviously, any particulate matter in the atmosphere will attenuate, will dampen the amount of sunlight that reaches the rooftops. And there were studies, because solar systems have real-time monitoring systems these days. And so you can see, as a cloud of particulate matter, as smoke is rolling over a landscape, you can see the dip in the amount of electricity being produced. And there were studies and articles produced when we had the devastating 2020 wildfire season that showed, you could see graphs of, here is the dip when the smoke came over, and you could see that dip. So yes, it does impact solar charging, just like any particulate matter or a cloud does. And thank you. I see we have full participation in the event survey. Super appreciate that. I'm going to go ahead and end that poll. All right, next we have a question. Typically, how long do you have paid for it with your savings on the utility bill? How long until you have paid for the system with your savings on the utility bill? So the question is, what is the payback period? The payback period is going to vary. And the reason is that the incentives that you have access to are going to vary. If you had access to the same incentives, your payback period would be roughly similar from person to person. Increasingly, Energy Trust of Oregon, with their Solar Within Reach incentive, which is available to most but not all people in the state, because not everybody's in those two main utility territories. That incentive, we saw in the example budget, say a PGE customer, if you're not income qualified, you might pay, $10-ish thousand for a system. If you are income qualified, you might pay $4,800 for a system. And so, but that's for the same 6 kilowatt system. And so the payback will be a little bit different. For the non-income qualified, which will be the longer payback period, it depends partially on how much direct access to sunlight you get as well. But you can expect maybe around 10 years at the long end there if you are not income qualified. If you have access to those income qualified incentives, you might see that it is somewhere around 5 to 7 years, something like that. So I would say think of it as a medium term investment to a long-term investment on the long end there. Another question, a solar contractor looked at our roof from attic and said we need to reinforce. Do we still need to get an engineer to look at it? If you are within Portland's jurisdiction, Portland, I believe, does require an engineer to look at it, even if a solar contractor can get in there and already eyeball it and say, you'll probably need that reinforcement. And the reason the engineer is necessary is because they will need to determine exactly if what reinforcement is necessary, and if that reinforcement, if it's going to actually then meet the load requirements for code. And so unfortunately, if you don't meet the requirements of the code and they know that, then you'll have to get an engineer, and the engineer might tell you that you need reinforcements. But you'll never get reinforcements without having an engineer look at it. Hal asks, do batteries work well during cold spells in the winter? That's a great question. Batteries, like all electric equipment, are temperature sensitive to a certain degree. There are some batteries that are particularly high performance in cold environments. If that is a particular concern of yours, you could talk to a solar contractor and make sure that the temperature where you're planning on installing the batteries is going to meet your performance requirements, and they'll help you select the right product. Question, can you add a battery later? Would that, excuse me, affect rebate eligibility? That's a great question. I do not believe that it affects rebate eligibility. I say that with about 95% confidence because I believe I know that, but I can't say that I remember that with 100% confidence. But I believe it does not affect your rebate eligibility. You can add a battery later. As long as the solar plus storage rebate applies only to batteries that are tied to solar. And so if you're asking, can you get a battery later after solar and still get a rebate? That is certainly the case. Can you add a battery after you have solar? Yes, you can. And it will mean the difference between something called a DC coupled battery and an AC coupled battery. And it may require one extra little bit of electrical component, but it's entirely feasible to add a battery to an existing solar system. Nancy asks, for storage needs calculations, if I don't need to power a fridge, but want lights, a small electric heater, maybe a room air filter and computer recharge, how do I make the trade-off between buying a big battery wired to the electric panel and something like Goal Zero, or is this the only difference whether the battery is wired to the appliances? So Goal Zero is for those who are not aware, it's a separate battery system that's kind of, you can carry it around. It's not a battery that you wire into your home. It's an external battery. And it's something you could charge from an outlet, say, and then just haul around and put it somewhere. You could take a look to see whether Goal Zero will meet your needs. I think your question here is about the voltage, because Goal Zero is probably 110 volts, but maybe your fridge is, I don't know if refrigerators are 220 volts, but regardless, I think that Goal Zero obviously exists to fill a niche. I cannot speak to these portable batteries and their specifications and their performance relative to other batteries that you wire into your home, unfortunately. But that's a good question, and I might do a little bit of research on that. I think my gut response, Nancy, is that either solution may work for you, so you could look at what the trade-offs are. Barry asks, do solar panels need cleaning? And if so, how often? Solar panels, the great thing is they are very low maintenance. The one bit of maintenance that they sometimes require that is recommended is cleaning them. And typically that's once per year. If you lived in a very dusty environment, say you were in Nevada, or say you live next to a very dusty construction zone, then you may need to clean your solar panels more often than once a year. But in the Pacific Northwest, especially where we get a lot of rain, sometimes people don't even clean their solar panels once a year. I think that it's a good thing to do it, once a year, but not more than that. So if your solar panels are within reach of a hose, and you kind of put your thumb over the hose and just kind of like spray up there with a hose, sometimes that works. Or you can increasingly find people, just a day laborer who will go up and with a little squeegee and wash your solar panels. Sometimes solar contractors can connect you with someone like that. Sometimes solar contractors will offer that as a service too. Kate asks, I hear incentives are going away. Can you comment? The incentives, so incentives are always over, the 10, 20 years that we've had solar incentives. They're always coming and going, changing a little bit. There are no immediate changes that I am aware of. The federal tax credit will go down at a certain point, and I really should know whether it's at the end of this year or the end of next year. And so that's something where you'd want to install to get that higher rate at the federal tax credit. Before that, the state incentive is that started in 2020, and they put, I can't remember how many $1 million they put in there. I think it was $10 million. It went really fast. And then they've replenished it. And I believe they've replenished it now twice. And it's the legislature that needs to replenish it. And so I think that last year they put in an additional 10 million. And then this year they might have put in an additional few million. And so when that's going to run out of money and not be replenished, I don't really know. So that's something that if you were to wait for 2 or 3 years, certainly some of these incentives could change. If you're considering going solar over the next few months, I would say you don't really have a whole lot to worry about in terms of changing incentives. Barry asks, any consideration given to location of panels to edge of roof so that snow avalanche does not take your gutters out? That's the first time I've gotten that question. Solar panels produce a little bit of heat, and so you don't typically have to take the snow off the panels. Sometimes the snow will just kind of slide off. Whether you characterize that as an avalanche may or may not be appropriate. But whether it takes the gutters out, I haven't heard of any issues with that. And I don't know whether it's worth putting your panels at an overhang over your house. There's obviously aesthetic considerations, but I'm not sure that that is on a pitched roof home. I'm not sure. You'd have to check to make sure that that is legal and follows construction codes. That would be the concerns that would come to mind for me, is whether it's possible to change where the panels end at the edge of the roof or whether they go over the roof. If you put them away from the roof line, I'm not sure. I'm not sure how to answer that question. I have no idea the likelihood of snow falling off of a solar panel damaging a gutter. But I will ask around with some solar contractors, and maybe if you email me, I can get back to you. And Nancy asks, and is a fridge more of an energy hog? That's a great question. Fridges historically have been huge energy hogs. I believe that newer Energy Star fridges are much more efficient. The thing about a refrigerator is it uses a relatively large amount of electricity over a shorter period of time because it's running a little, it's a little motor to cool it down, and then it stays in a period of dormancy for a while. I'm not really sure I can answer your question. I know that older fridges certainly are a huge energy hog. And that's it. We have no other questions in the Q&A. If you have another question, put it in quickly, and I will be happy to continue to answer them. Otherwise, I am really glad that you all joined us today. I hope that this, we have one more question before I end. So Barry asks, can battery provide two-phase electricity? There are two-phase and three-phase. It's not about the battery, it's about the inverter, I believe. And that's another electrical component, kind of like your solar inverter. But yes, two-phase, three-phase, there will be battery solutions for you out there. So yes, thank you so much for joining. I hope that this was helpful. Again, feel free to contact me, zach@solaroregon.org. I'm here to be a resource for you to help you along your solar or energy storage journey. Feel free to check our website for upcoming events. We do have a showcase on March 31st of a just a really cool site out in East Portland on Northeast Sandy. It's in person and it's a limited audience, and it's for Morrison family and youth services, and just a great story to learn about that site. So take a look on our website soon. Hope to see you around at a future event. And until then, take care.